Okay, so here's our last kind of problem. Something we're going to expand into is now not just looking at prisms, but what if the bases are circular? So what if we're dealing with a cylinder instead of a prism? So if we think about, if we remember that when we talk about our regular polygons, if we keep adding more and more sides, the formula doesn't change. But if we add more and more sides, our base becomes uh, more and more difficult to distinguish between one side and the other. So it becomes more and more circular looking. So really, if we have a circular base, there's no difference in calculating our surface area and volume. So just like we did before, our surface area is going to be 2, nope, I'm sorry, let me undo that. Our surface area is going to be our perimeter times our height plus 2 times our base area. But here's the thing, because it is a circle, we know that there's a couple of special formulas. So when we talk about circles, we say the perimeter, we have another word for that. Perimeter is the same thing as the circumference. And so when we think about the circumference of a circle, we actually have a formula for that. So our circumference is just 2 pi r. So we can say, instead of the perimeter, we can say 2 pi r times the height. And the area for a circle, the area is always the same, and that would be our pi r squared. So we would get the area of the circle on the bottom and the area of the circle on the top, or vice versa. And we have 2 of them, so we'd say 2 times pi r squared. So really, what's great about cylinders is that we only need to know what's the radius and what's the height, and that will help us calculate our surface area for the cylinder. So in this shape, our radius is from the center of the circle to the edge. Our radius is just 5, and our height is just 8. And we're going to leave our answer in terms of pi here. So basically, it just means that we are going to multiply, the r and the h instead of just 2 pi. So we're going to say our 2, I'm going to ignore the pi, even though I'm going to write it down here, times our radius, that's our perimeter, times our height, plus 2 pi, and then our radius squared, so 5 squared. So when we try to put this all together, we have 5 times 8 would give us 40, and we're going to multiply that with our 2. So we've got 80 pi here. That would be all of the curved surface around the outside of our cylinder, and then plus the top and bottom. So our 5 squared would be 25, times 2 would be 50. And so then we just add them together, like terms. 80 pi plus 50 pi gives us a surface area of 130 pi. And it's just going to be units because it doesn't say units squared. And that gives us all of our circles plus all of the wrapping around the middle. And so then when we look to do our volume, we can say the same thing. It's just that circle stacked over and over again. So it is just our base area times our height, which again, though, because it is a circle, the base area never changes. So we can say it's just our pi r squared times the height. And so here again, we know our radius is 5 and our height is 8. So really it's just 25 times 8. So 8 quarters, that would give us a volume of 200 pi, and units cubed on there. And that's how we do our volume for cylinders. So cylinders are actually pretty straightforward because their formula, the shapes never change in a cylinder. It's always circular. Whereas prisms, you could have rectangles, you could have triangles, you could have hexagons. So prisms are a little more difficult. Cylinders are a nice straightforward formula. So then the last thing we have here is what happens if we took that cylinder and we tilted it a little bit. So what happens if it slants like it's shown in the diagram? So when we see this slanting, we call it an oblique cylinder or an oblique prism. We could have the same thing if the prism base was tilted. So if we had something like this, if we tilted it instead of having it drawn straight up. Oops. So Would the volume of this cylinder increase, decrease, or stay the same if the prism or cylinder is slanted? So what I would say, what I would urge you to think about is think about a stack of pennies. So in this case, because we're dealing with circles, if I had a bunch of pennies stacked up over and over and over again, straight up, we would have, I don't know, let's say here we have 1, 2, 3, 4, 5 pennies stacked up. If I was to push some of those pennies so that it started tilting, would I still have the same number of pennies? Yeah. So, and each penny has its own volume, and so then even though they're tilted, they're still taking up the same amount of space, and that's really what volume is. Volume is just the amount of space that the object is taking. So if we were to stack 5 pennies vertically or stack 5 pennies where they kind of look like a stair step, has their volume, the amount of space they're taking up, changed? And really we could say no. The volume is going to stay the same because they're taking up, so I'm going to say the shape is still taking up the same amount of space. This is why I type everything, because my handwriting is horrible. There we go.